Hello, everyone. Welcome to today's session. My name is Wycliffe, and in today's session, I want to share with you how to uh, handle geometries or work with your geometries in RGEE. Now, geometries are fundamental in RGEE because, or in Google Earth Engine in general, because we use it or we use them to filter bounds or filter our region of interest or extract some variables for our particular geometries. So everybody is asking you what is the NDVI for my location or asking you what is the mean elevation or something like that. So the geometries are what handle that. Okay, so we will start by loading libraries. So of course, the main library we are using is the RGEE. So we load that. We will also need map edit to draw some polygons and lines and points. We will need leaflet. So we call library leaflet. This will help us to set our base map. And then lastly, we will need a library called SF, right? Then just the three different types of cases which we will be working with include one, when we have to create points or a point or a line or a polygon. Also, we will create a rectangle and polygon. So we can create those in R to work with the Google Earth Engine, right? The second one, I will show you how you can use map edit package, which we've loaded in line 2 to help us do the same. And then we'll also see how we can get them from our own source. So on polygons or on vectors, if you have your own spatial data like vector, raster, especially the vector data, points, lines, polygons as a shapefile or GeoJSON or GeoPackage, how you can bring them into your RGEE or use them in Google Earth Engine using RGEE. Okay, and then lastly, we will look at how we can obtain these from Google Earth Engine catalog, data catalog. Yeah, yeah. Okay, so those are the four methods we are going to digest in this session. So, of course, we need to initialize our Earth Engine session using EEE initialize. And then for this case, I will set drive to true, even though we are not going to do any exportation, but it's a good thing to have to set to true. Okay, we'll start with the point. But before that, we can just center our map at our region of interest where we are going to do our analysis. So we can set that using map function, map, and then we say set center. For the set center, we provide the longitude, we provide the latitude, and we provide a zoom. So for the longitude, I want to center this around longitude 35 degrees or 35.133. And then for the latitude, I want to center this map at latitude negative 0.4, 468. And then the zoom level, which ranges from 1 to 24, with 1 being the highest, with 1 being the lowest and 24 being the highest. So we'll zoom it at that. If we run map alone, we see that our map is zoomed to the region of interest where we provide the latitude and longitude. This is basically a location in Kenya in a tea growing region, particularly around Kabianga University. This is a university which sits at the center of tea growing region and probably a nice place to run research on T. Okay, so if you want to create a point, let's start with point. So if you want to create a point vector, you just say, for example, we can call it point like that. Then we use Earth Engine geometry, and then we call point. Then to this point, we provide the coordinates. So the coordinates that we want can be, we provide the longitude, for example, 35, the same longitude we had here. So we can provide this value here. And then the same latitude we had up here. Let's say we want that to be our point feature. Okay. So when we run that, our point is set. We can add this point to our map. So map $, add layer, and then point. And this point can be anywhere globally. It does not necessarily have to be these coordinates. You can put your own coordinates. Just make sure that this is longitude and this is latitude. The first is longitude, the second is latitude. You can provide them directly like this, or you can provide them as a vector with C, and then like that. That is still acceptable. You can still add the point, and you see it located there. You can also provide them as a list. So you can call it a list, and then you provide a map, and then you get your point. So you can then use this point to maybe filter bounds of image collection, or to extract values for that particular point. All right, so the next one we are going to look at is a line. So the geometry line starts from, is at least 2 points. So if we have 2 points joined, then we already have a line. Okay, so for the line, we can call it maybe LN, or line, like that, link. Earth Engine, then we call geometry, and then for this, we call line string. Not ring, but string, right? So for the line string, we provide a vector of coordinates with X and Y in that sequence. So let's say one of our first points, or our point, starts from longitude 35.133, and then latitude negative 0.4468, the exact coordinate we had up there. And then it goes to a point. This line goes to the next point, which is longitude 35, maybe 135 up or to the right, and then goes to negative 0.43, maybe 68. So that is a bit to the north. And then it comes down again to longitude 35 degrees, 0.136. And then for the latitude, it goes to negative 0 point, maybe 445. Okay. So that gives us a line string geometry. Control Enter. Something is not right. Linear. Okay, it should be line string. Okay. Yeah, so that's fine. And then we can add it to our map.add layer, map $add layer, sorry. And then we put our line. So if you check on the map, you will see a line. At least it started from one point, went to another, and the last. So if you have a series of or several points, coordinates, and you want to join them to a single line, you can use a line string. Lastly, we can draw a rectangle. Okay, so we can say rectangle. And for the rectangle, let's say rect, we use EE geometry and then rectangle. Okay. And for the rectangle, we just need a pair of coordinates. We need the bottom left and the top right. Bottom left and top right, and a rectangle will be drawn in that location. So we can provide them as a vector again, and we say, for example, the first point is 35.13. Longitude and latitude is negative 0.45. Okay, and then the next coordinate is, or the top right is 35.15, and then negative 0.435. Okay, so if we run this, we create our rectangle and we can add it on the map using map.addLayer. Map $add layer, sorry. And then the layer we are adding is rect. So we will see our rectangle as a geometry. Okay. And we can also do the same for a polygon. So for the polygon, we can say for the poly, we have EE $geometry $polygon. And then for the polygon, we will have more coordinates. So I will provide some coordinates here, like 35, several coordinates, but the main thing is that the first coordinate and the last coordinate should be the same so that the loop is complete. That's what separates it from a string. Okay, so 35, maybe 0.12709. That's the first coordinate, and then its corresponding latitude is negative 0.45349. And then the next one is 35, the next point, 0.12159. And then this is having a latitude of negative 0.43976. Okay. Then the next point or coordinate for this is 35.12709. 12079, for example, and then it coincides with negative 0.42 or 2827. Okay, and then the next one, the fourth coordinate, we can put 35.141, maybe 77, and then this coincides at the same latitude of 0.42827. Okay. And after that, we can have another coordinate, 35.14599. And it coincides with its corresponding latitude coordinate is 0.43976. Okay. Second last, 35.14083. And it coincides with negative 0.45349. Okay. And then lastly, we have 35.12709. As you can see, I said the last and the first are basically the same coordinates. So we can just paste that there. Okay, we have our polygon. And for this polygon, we can also use map add layer. And then we say poly. Okay. And we can see a polygon around our area or specific area of interest. First, second, third. The third coordinate, maybe I didn't enter something right. So 42827. Yeah, that's fine. Okay, so that's how you can get your line, your point, your line if you have the actual coordinates, or a rectangle if you have the bottom left and top right, or a polygon if you have several coordinates that close in the end. The second way, or if you want, maybe somebody wants to visualize this, you can add a better map on, for example, for this polygon by saying, say, poly poly gets, if you don't want to fill in this gray color, you just want the borders, then you can style it with EE. You can convert it because currently it's a geometry. If you print poly, you can see that it's an Earth engine geometry. So you can convert it to a feature collection, for example, feature collection using for the poly, not the rectangle, for the poly, and then you style it, right? So in the style, that's where you can provide a color. So this will be the border color. And the color we are going to provide is the magenta color, which is FF00FF, right? And then for the fill color, we are going to use transparent color, which is hash 123, 123, and then 00. So that's transparent color for the fill. And then we can say, give it a thickness of about maybe 6 so that it's visible. Okay. So if we add layer for this, if we say map $ add layer for poly, then it will be just the boundary which is shown in purple or in magenta, but inside it is transparent, like you can see everything here. So that is achieved by making it a feature collection and then adding a style to it. All right, so let's go to the next step, which is creating a map using map edit package, or creating point, line, polygon using map edit function. So for that one, we start by creating, let's say, M point. So using map edit, we use a function called draw features, and then we can convert this to SF as EE. Okay. So when we run that in this map edit, in this leaflet area or map, we can pick a point using this drawing tool, which is called draw marker. And then we mark a point of interest. So again, let's get this. And then I can go towards the area we were working with and pick a point. And then click done. So with that, you have obtained your M point. The next, so that we don't keep clicking here and looking for the imagery, we can create a map. And then using the leaflet function, we can add tiles, base map. So add provider tiles. And then we provide a provider which is called ESRI dot world imagery. Something is not right. Provider not found. Provider ESRI dot world imagery. Leaflet, and then add provider tiles. Provider not found. Yeah, it's supposed to be providers, right? Okay. Then we can create a line, which is M line. for example, mlin, again, using draw features. And then automatically we convert our feature to Earth Engine object using SF as EE. So again, we get this leaflet area and we zoom to our area of interest, changing the background to world imagery. Actually, we can already set that here. When we are drawing this, we can already say map is equal to M because we set it up here. So by default, it will give us a world imagery background. All right. We can escape that first, then we draw the second one. Okay. So we can zoom to our area of interest and then create a line feature. So a line feature, we pick the top, which is draw polyline, and then click, 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 click as you draw your line of interest, but we don't loop it to the end. Then we click this finish, and then we click done. So with that, we have our M line as an Earth Engine object, which we can use in the backend with Google Earth Engine. So our next features is, or our next feature is rectangle. So again, we will convert it also to EE. Okay, we can set this map again to M because we have it. Let me escape that. Escape, clear. Then we can run this. So again, we zoom into our area of interest and then create a rectangle. Rectangle, we use this, which is draw a rectangle, click on top, and then drag to your area of interest, then click done. The last, or we can also draw a circle marker, circle. So again, we use draw features, and then map we set to our base map, which we created for the leaflet with the tiles preset, and then as EE, so that whatever object is created is automatically converted to an Earth Engine object. Okay, so again, to the area of interest, we have this circle marker or draw a circle marker. So we click on it and pick our area of interest and then click done. Lastly, we can draw our polygon. So we can say M poly. And for the M poly, again, we use draw features and we set our map to M, and then we pass that to SF as EE. All right, so again, we zoom into our region of interest or wherever we want to draw that feature or that polygon, and then we click this draw a polygon. And then within our region of interest, whatever feature you wanted to draw, but remember to click the last point. Then it's now a polygon. Then finish, click finish, or just click done. That should be it. Okay, so all these objects are actually Earth Engine objects already. So we can call, for example, map.addLayer or $addLayer, and then maybe mrect, and then we will see our rectangle drawn, and everything is happening in the background in Google Earth Engine. We can use them to filter our region of interest and filter bounds of satellite images or other images on vectors. So if you have your own polygon, if you have your own polygon shapefile, GeoJSON or shapefile or GeoPackage, then you can still read them on Polygon. You can all still read them using SF package like stread, which we already loaded our SF package up there. You can still read your own uh, your own polygon, GeoJSON, GeoPackage, or shapefile, depending on the path where you located it. So it can be C, users, blah, 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 up to the data. Mine is in the working directory, so I can just run this, and I have my own polygon brought, and it's a GeoJSON. It's a GeoJSON. Probably you have a SHP, or you have a geo package, GPKG. For my case, I have a GeoJSON. Okay. So once you have your own poly, again, you can pass it to SF as EE. If you read your data using vect from Terra, for example, then you need to convert it to SF object using ST as SF. Okay, so we have our own poly, which you can still add to the layer, map add layer, and then we provide on poly as the geometry, and we can see where our own poly falls. So that's a polygon which I digitized earlier and then saved as in my working directory. So you can bring your own polygon. It can be a point, it can be a polygon, it can be it can be a point, it can be a polygon, it can be a line, it can be a multi-polygon or multi-point or multi-line. The process is the same. You just read it with appropriate geospatial package function and then convert it to EE from SF and then add it to layer. Okay. Finally, we can also obtain geometries from Earth Engine catalog. So I already previously mentioned to you, for example, if you want global administrative layers, then you can just say Earth Engine $ feature collection, because you know that's a feature collection. And then you look for the data set. And then if you put a $sign, you will see the list of all features or feature collections that are in Google Earth Engine data catalog. So for the dataset, for this dataset, we want level 0, for example. And then if we run this, we have our GAUL, GAUL, which is a Earth Engine feature collection. And we can add it to our map. So we can say map $add layer, and then global administrative layers. So that gives us the boundaries of all countries in the world, right? All countries in the world. Let's say you just want to pick Kenya, or maybe not Kenya. You want to pick Chad, for example. So if you want to pick Chad, then you can say Chad. You can either use a point, for example, the points that we were creating here to filter bounds, or you can filter it from the attributes of the whole dataset, because here in Gaul, we have attributes referring to the names of each country. So we use Gaul, and then we filter. The filter we are using is Earth Engine $filter $equal. So we are looking at the administrative 0 name, that is the first administrative level, where the name is exactly equal to Chad, right? So we can say, we can run that. And then if we add on our map, sorry, not CHAP, but Chad, we should be able to see the map of Chad. Yeah, Chad is selected. So we've filtered just for Chad. So if you want to do your analysis for the country Chad, then that's how you filter and get all the analysis you want, whether it's NDVI, biomass, degradation, whatever, population, anything you want to do with that particular polygon. The next way to pick a point or a feature from this collection, a specific country, is, for example, if you want Zambia, right? So if you want Zambia and you know the location here, the longitude and latitude values that fall inside this Zambia, then you can filter for it, say Zambia, and then from GAUL, or from our feature collection, which has got all those countries, we say filter bounds. Filter bounds. And whatever we are using to filter bound is the point here. So we need to create a point for Zambia. So let's say point Zambia. And we say EE $geometry because we already know how to create point, geometry, and then point. And for this point, when I'm in Zambia here, I can see maybe around Lusaka, anywhere, provided you're inside the polygon. So there are values here which I see like 19 point something, 20 point something. The longitude and latitude, I'll pick them. So we have, for example, 27.007. That's what I'm seeing up there, and 1. Then the latitude is negative 14.34785. Okay, Control Enter or run. So we filter bound using Zambia point. So from all features in the feature collection of the globe, filter for me where the feature that touches or touches the Zambia point. Okay, so if we plot Zambia, or if we add Zambia on our map, we should be able to see the map of Zambia down here. So this is Zambia because the point we were using spatially filtered for this particular feature inside the feature collection. If you had a feature which captured more than 3 or 4, if you wanted maybe Central African Republic, South Sudan, and Uganda, then maybe we can call it many countries. Then we can use draw features. So we use draw features and then we convert it to SF as EE like that. And then we know, for example, we want Central African Republic, South Sudan. So you just draw a polygon that touches them or whatever, provided that it's intersecting with those countries you are interested in. And then we say done. So my countries here, we can now, many countries here, we can now use it to filter our Gaul. So we can say countries is equal to global administrative layers and then filter bounds. And then we are filtering bounds using many countries like that, right? And then now if we add to layer the countries, then it will be the countries that touched that our region of interest, which we picked. So there'll be several countries, including, all these countries were touched by that. So we can select more than one. It doesn't have to be one. Okay. So that's what I wanted to share with you today. I hope you've learned something, starting from creating your own point, creating a line feature, creating a rectangle, and even a polygon. Also, I've showed you how you can plot your polygon feature using by only having the borders without filling the polygon. We also showed how we can create these ones easily, features easily, whether it's a point, a line, a rectangle, circle, or polygon using map edit. Then finally, second last, we showed how you can bring in your own shapefile and then use it or GeoJSON or GeoPackage and then use it in Google Earth Engine to run your analysis. Okay. Also, we showed how you can rely on the data which is already available in Google Earth Engine, how you can obtain it for your particular region or by specific name you want. And then how you can also obtain more than one feature from the collection, provided they intersect with your region of interest. Okay. Thank you so much for your attention. If you find this video useful, stay in tuned. You can like, you can subscribe, and then we will get more in this November map challenge. Thank you and happy coding. Bye-bye.